Could you start by introducing yourself and your school?
Oh, no problem. Hello, my name is NikeAdewuyi. I am an MD PhD student at Northwestern University, and I perform research at the Center for Bionic Medicine in Chicago, Illinois.
And can you tell us a little bit about your research?
Oh, no problem. So overall, my research involves the control of prosthesis, specifically for partial hand amputees, and those are individuals who have lost their hand anywhere from um, distal to their wrist and beyond. So it could involve any number of fingers and any level through the hand.
And why is that condition more challenging than some other amputees?
So for transradial, and transhumeral, someone who's lost it in their lost part of their forearm or their arm, it's a lot easier for them to fit with a prosthetic device. So a lot of times it's a nice clean cut the surgeon makes, and you can easily make a socket, which is what attaches the residual limb to the device and attaches to the individual. But for partial hand amputees, they can present in a lot of ways. It can be any number of fingers, it can be any level through the hand, and so it's a lot more difficult to fit them with a prosthetic device. And so it's been, in terms of the technology available, they've had fewer options up until recently. So in 2009, Touch Bionics came up with the Pro Digits hand, which has 5 independently functioning fingers and a motor in each finger. And so mechanically, each finger can move independent of each other.
Right.
Now the challenge is, how do we control this, right? And so right now, the subject can only open or close their hand.
Right.
And so you want to take advantage of the capabilities of that device and provide more functional hand grasp patterns to the partial hand amputee.
So tell us about the work you did in the lab for
Okay,
that.
no problem. I'd love to. And so what I did, I recruited 9 able-bodied subjects, so they had fully intact arms and hands, and I attached electrodes, and these are little sensors that pick up the electrical signals from your muscles, and I attached them to their forearm and their hand just to get a sampling of those signals from all those muscles. And then I asked them to do different finger motions, flexing and extending each finger and moving their thumb, adducting their thumb. And then I asked them to do different functional hand grasp patterns, like doing a fine pinch or a key grip or a chuck grip. And as they did those grasp patterns, I recorded these electric signals from their muscles, and then use that information to sort of program something called the machine learning algorithm. And so what that is to give you some background, I know you've probably heard of facial recognition,
Sure.
right, where you take some features of the face and you use that to sort of identify the individual. And
Right.
so similarly, you take features of the electric signals, which you call EMG, and use that to identify the hand grasp pattern or the finger motion. And so when you can take the EMG information, put it into this algorithm, and then train the algorithm. And so the next time it sees some pattern, it can identify what that pattern is associated with. Is this pattern associated with opening the hand? Is it associated with closing the hand? Once it can identify that, we can use that information to then control a prosthetic device.
So the algorithm could recognize a patient's like, oh, this is trying to grasp a small penny, and give them finer control than just what you're saying about opening and closing.
Basically, and so you would train the algorithm, and so you would give it training data. Basically what that means is you would collect information when you say open the hand and close the hand. You would tell it this pattern corresponds with opening the hand, this pattern corresponds with closing the hand. So now if you give it an unlabeled pattern, it'll compare it to its prior knowledge and say, oh, this pattern looks like they're opening their hand, this pattern looks like they're closing their hand. And for the most part, it's really accurate.
Right. So where do you hope to take this research?
Hopefully our research is clinically relevant, and so we want to take that information and use it to actually control prosthetic device. And so, in a couple of years, you want to be able to, say, give a partial hand amputee the ability to control several grasp patterns, which is something that they can't do right now.
Right.
And what's interesting about this method of control is that it's more natural. The way they're controlling it is the way you and I control our hand. We think, opening hand, we send the signals to the muscles and it opens the hand. We're picking up that same signal and we're actually do the same thing that they normally would if they wanted to open or close their hand. So the learning curve is a lot lower than, say, other methods of control where you're attaching the electrodes to a different muscle that naturally does something else.
Right.
So now they have to learn that, oh, bending my wrist would mean opening the hand, and it's a little bit more confusing.
So how far away are you from doing trials with patients that actually are missing limbs?
Well, in terms of clinical trials, they're far away from that, but I aim to work with partial hand amputees in the next couple of months to collect information from them. Yes.
Well, thank you so much for taking the time. That was
Thank
very
you.
interesting.
No problem. Glad to be of help.